Have you ever wondered about this seemingly paradoxical question? The universe contains countless galaxies, and our Milky Way alone holds hundreds of billions of stars. With such an enormous number of stars, it seems intuitive that their light should fill the entire sky, turning the night into a vast ocean of brightness. And yet, when we look up at the night sky, what we actually see is deep darkness, punctuated only by a scattering of faint stars. So why does a universe overflowing with light produce such a dark night sky? This mysterious question was raised long ago. In 1823, the German astronomer Heinrich Wilhelm Olbers was the first to frame it systematically as a scientific problem, and it later became known as Olbers Paradox. He proposed a bold idea. If the universe were truly infinite in size and filled with infinitely many stars spread out in every direction, then no matter where we looked, our line of sight should eventually end on the surface of a star. If that were true, the night sky should not be dark at all. It should shine continuously, perhaps even as brightly as daytime. But reality is clearly very different. Imagine standing in the middle of a dense, ancient forest. At first, when you look in any direction, you might see small gaps between the nearby trees. But the farther you look, the more those gaps are filled in by trees farther away. Layer upon layer, the trees block every opening until all you can see is a solid wall of green. In this comparison, each tree represents a star. If stars were truly infinite in number and evenly distributed throughout space, their light would behave in the same way, stacking layer upon layer until every dark patch in the sky disappeared. That contradiction lies at the heart of Olbers' paradox. So why is the real night sky so different from the brilliantly lit picture the paradox seems to predict? First, consider the staggering scale of the universe. Current scientific estimates suggest that the universe may contain at least 2 trillion galaxies. Each galaxy is a vast stellar city, with a number of stars comparable to or even greater than the Milky Way, roughly 200 to 400 billion stars. Multiply those numbers together, and the result is almost beyond comprehension. The universe may contain on the order of 400 sextillion to 800 sextillion stars. With an ocean of stars that immense, their light should seem capable of flooding all of space and making the night sky glow as brightly as day. Yet that is not what we observe, and it is precisely this contrast between the enormous number of stars and the dark, quiet sky above us that leads to the central question. What is it about the structure and history of the universe that prevents the light of all those stars from filling the sky? In the classical version of Olbers' paradox, the universe is assumed to be static, eternal, and infinite, with infinitely many stars. Those assumptions lead to an unavoidable conclusion. Starlight would have no end. It would travel outward from countless luminous sources, layer upon layer, eventually filling all of space. Like an infinite wall of light bulbs, even the most distant stars would still contribute to the overall brightness. In such a universe, the night sky could not truly exist. Space would be flooded with continuous, everlasting light. But what we actually observe is the exact opposite. The night sky remains dark still and only sparsely dotted with stars. That tells us something important. At least one of the paradox's basic assumptions must be wrong. For a long time, people believed the universe was static, unchanging, and eternal. But that view was overturned when Edwin Hubble observed distant galaxies and discovered a startling truth. Nearly all of them are moving away from us. Even more remarkably, he found a deeper pattern. The farther away a galaxy is, the faster it appears to recede. It is as though the space between us and those galaxies is continuously stretching. From this, Hubble concluded that space itself is not standing still. The universe is expanding in every direction. This expansion is uniform and universal, meaning that no matter which galaxy you stood in, you would see other galaxies moving away from you as well. Every galaxy can appear to be at the center of the expansion. No single location is uniquely special. The greater the distance between galaxies, the faster they move apart. This elegant and powerful relationship became known as Hubble's law, and it fundamentally changed humanity's understanding of the universe's structure and fate. Hubble's discovery did more than explain how galaxies move. It also opened a new path toward understanding the origin of the universe itself. By tracing that expansion backward in time, scientists realized that the universe must once have been compressed into an extremely hot, dense state before expanding outward into what we see today. This became the foundation of the Big Bang theory. From the present rate of expansion, scientists estimate the age of the universe to be about 13.8 billion years, a timespan so vast it stretches far beyond ordinary human imagination. One especially important point is that the expansion of space is not limited in the same way as motion through space. Galaxies are not necessarily traveling through space faster than light. Rather, the space between us and them is expanding. As a result, there are extremely distant galaxies whose light will never reach Earth. This leads to the idea of the observable universe, the portion of the cosmos from which light and information have had enough time to reach us. Anything beyond that boundary may exist, but it remains permanently beyond our ability to observe. And this is what resolves the core of Olbers' paradox. The universe we can observe is not infinite in the practical sense. The number of stars whose light can actually reach Earth is finite, limited by both the age of the universe and the expansion of space. Light from countless distant stars has simply never reached us, and in some cases never will. That is why their light does not fill the night sky. In this sense, Olbers' paradox is no longer a contradiction. Instead, it becomes strong evidence in support of the Big Bang and the expanding universe model. The darkness of the night sky is not a sign of an empty universe. It is a direct imprint of a universe that had a beginning, has a history, and is still expanding. There is, however, a more practical question to ask. Does the night sky we see really give us an accurate picture of the universe? Not entirely. What our eyes can detect is only a tiny fraction of the full cosmic picture. On a clear night, most of the stars we see belong to our own Milky Way. Under ideal conditions, the naked eye can detect only about 3,000 stars at once, while the Milky Way alone contains at least hundreds of billions. That enormous difference shows just how limited human vision really is. Our eyes can only detect relatively bright sources, while the vast majority of stars are simply too faint to see, and that is not the only limitation. We observe the sky from the surface of Earth through a thick atmosphere. The atmosphere scatters and absorbs some starlight, weakening it before it reaches our eyes. On top of that, modern cities produce severe light pollution, drowning out the natural darkness of the night sky. That is why the stars appear far dimmer in urban areas than they do in deserts, mountains, or remote countryside. Even in space, starlight does not always travel unobstructed. Within our galaxy are vast clouds of dust and gas that act like cosmic curtains, absorbing and dimming the light from many stars. Some stars are hidden from view altogether. In other words, the night sky we see is not a complete portrait of the universe. It is a filtered version, shaped by Earth's atmosphere, artificial light, and the dust and gas within our own galaxy. And there is one final limitation: our eyes themselves. Sometimes what we call a dark sky is not dark because nothing is there, but because we lack the ability to see what is there. One of the most powerful demonstrations of this is the famous Hubble Deep Field image. The Hubble Space Telescope was aimed at an extraordinarily tiny patch of sky in the constellation Fornax and collected light from that region over a long period of time. This patch covered only about 1/12 millionth of the entire sky. To the naked eye, it looked like an empty, dark spot with nothing of interest in it, but when the image was released, the scientific world was stunned. In that seemingly empty patch of darkness, Hubble revealed more than 10,000 galaxies, and each of those galaxies contains hundreds of billions of stars. An immense cosmic ocean had been hiding in a place that looked completely empty to human eyes. That moment taught us something profound. The darkness of the night sky is not evidence of emptiness, but of the limits of human perception. Beyond what appears to be darkness lies a vast universe quietly shining beyond our sight.